First part of our last lesson, lesson 5, talking about expected value. We're going to do some calculations with geometric probability, end of a geometry sequence, that kind of makes sense. And then lastly, what it means to have an expected value of an event. And it's along the lines of how you would contemplate how many times do I have to play the slot machines until I start getting payouts. And spoiler alert, it's a lot. Go ahead and highlight our key terms, geometric probability and expected value, and then highlight our learning goals for this slew of lessons. Determine geometric probability and calculate the expected value of an event. With those words in mind, let's do some spiral review. Determine the area of each unshaded section. Unshaded, okay. I'm flipping my brain around from when I thought about these questions in the beginning. Let's start with question 1. I do have a yellow calculator over there, so make sure that you have, or for me it's that color, but you get a calculator, and Desmos works, but it's good practice to use these TI Inspires. These two areas that are unshaded, they form like two triangles. Excuse me. The area of a triangle is pi r squared. No, I'm thinking circles. The area of a triangle is base times height divided by 2. So when I look at those two shapes, this triangle right here and these two unshaded sections, they fit together, but they still follow the rule of base times height divide by 2. And since there's 2 of them, that's where the divide by 2 adds together, so we get the full rectangle shape. So as simple as we can make this one, it'd be the base of 9. Oh, I should write the 9 here instead of a B. And a height of 6, and then we divide by 2. And so 9 times 6, if you know, fingerman multiplying by 9s, especially 9 times 6, you fold down the 6th finger. Is that working for you? No, this way, right? So it's 54 is 9 times 6. If you've ever seen that before, that's what that is. 54 divided by 2 is 27, and so therefore, for number 1, the answer for number 1 is 27. We want the unshaded, by the way. And so in the question number 2, the unshaded would be these little, they're not wedges, they're corners, but they're like if the circle was taken out of a square. Then that's what we're going to do geometrically. So if I have an area of what's left, it'd be the area of the square subtracted by the area of the circle. Now, the formula for area of a square is side times side. And so since there's a 10 on the side of this, the area of this whole square is 10 times 10. Or 10 squared, that reason alone. The area of a circle, the formula for area of a circle is pi r squared, where r is the radius. And the radius is not 10 for this circle, because 10 would be all the way across, and the radius would be half of the way across. So this has a radius of 5, which means the area of the circle will be pi times 5 squared, because 5 is the radius and it's half of that full diameter from side to side. So this is like the full right answer, but it'd be helpful if we had it written either in decimal form or with a little bit more clean, like exponents. Come on, we can do exponents. We can do 10 times 10 is 100. 5 times 5 is 25. And then if I go 25 with pi at the end, this is the exact answer, just like 27 was the exact answer. Now it would be good to have a decimal value. So calculator, scratch work. What is, press too many times. What is 100 subtracted by 25 pi? There it is. 100 subtracted by 25 pi, enter to lock it in. Oh, this one gives me the exact answer. That's somewhat annoying. So if I go control enter, it'll give me the decimal. And the decimal is 21.46. Square feet. That's right. These are in feet. That was in centimeters. So I have square centimeters. This one I have square feet. Now, in the last one, it's just a circle. It's just a circle, and we want the unshaded section. So the section that is shaded is 1/4 of the circle. That's that 90 degrees in the middle, a fourth there, and then it wraps around a fourth and a fourth and a fourth. So this unshaded section is actually 3/4 of a full circle, which a full circle has the formula for area of pi r squared. But right here, we can see that r is 2 inches. So plugging all of that in, 3/4 times pi times 2 squared, 2 times 2 makes 4, and that's a 4 on the top of the fraction, while the rest of this is on, like over 1. So this 4 and this 2 squared will end up reducing. It makes 4 over 4. When we reduce them, we're left with 3 pi, and 3 pi is a nice exact answer, and most of the time it'll be the right answer to leave, but I'm also going to go into here and go 3 pi Control Enter is approximately 9.425. 9.425 square inches. All right, that is it for our spiral review. Let's get into the lesson. Go ahead and click forward on page 894, and I'll see you in our conversation around geometric probability and expected value. See you in the next episode.